Dear students, you already studied about relations and functions. But once again, I revised relation and function. First, in the previous class, I discussed about relations. Today, I shall discuss about functions. You studied functions in the first PU class also. Here once again we recall function. Here function is one of the relations, but all relations are not functions. Here if A and B are two non-empty sets, then F is a function from A to B is a relation from A to B. A function F from A to B, A into B is a relation from A to B, from A to B. But there is some condition such that, which is the conditions such that for every element or every A belongs to A, every A belongs to A, there is an ordered pair. There is an ordered pair. Ordered pair means AB belongs to F, where B belongs to B. B belongs to B, and if AB is belongs to F and AC is belongs to F, then B is equal to C only. Here, if A and B are two non-empty sets, a function f from A into B, a function explained like from A to B is a relation, is a one of the relation from A to B, but such that for every element A belongs to E. Every element of A means domain. It's a domain of element of domain. There is an ordered pair. Every element has an ordered pair. Such belongs to AB belongs to F. Where B belongs to B. Means f of x is equal to B. This is the element of B. This is why it belongs to B. Here, but A and B, AB belongs to F and AC also belongs to F. B and C are equal only. That means a function is explained like this. It's an A, it's an B. It's a function. If it's 1, 2, 3 or 5, 6, it's the two sets. A and B are the two sets. If the element of domain A is paired with the element of B, then if it is paired with another element of 6, it is not a function. In the same way, also it's a function. But if it's one element should have only one image, both one image, one element of domain. Every element of domain should have only one image. Separate element have same image is okay, but every element of A should have only one image. Don't have one element have two images. But here it is a function. It's a function. Another example. 1, 2, 3, 4, 3, 5, 6, 7, 8. Here, it's a function. Here 8 is not an image of the element of domain A, but it's a function because every element of A has an image. One is image of 1 is 5, image of 2 is 6, image of 3 is 7. 8 is not an image, but every element of A having the image. Therefore, it's a function. Here, A is equal to 1, 2, 3. You already know it's a domain. It's a domain. And B is equal to 5, 6, 7, 8. It's a codomain. It's a codomain. It's a domain. It's a codomain. But range is the element which having the images of the domain. Which are the images? 5, 6, 7 is the elements are the range. It's equal to range. 5, 6, 7 is the set of images. It's the set of images or range of the function. A is the domain. The elements of A, domain element. 8, 5, 6, 7, 8. This is the B elements are called as codomain. And range is the set of the images. Set of the images. I think you clear about the function. Function is any function from A to B. Every element of A having one and only image. One and only image. Every element should have only image. Every element should have the image. Every element should have, if it is 4, if it has no element, no image, it is not a function. Every element of A or domain should be paired with the element of the codomain. And every element should have only one image. One element should have only one image. Two conditions you should remember. Every element of A should have image in codomain or B. And one element of A or domain should have only one image. Every element of A should have one and only image. Every element of A has only one image. It's a function. You already studied in the first PU class many types of functions. What are the functions you studied in modulus functions, sinum function, etc. But here in second PU, we study some special type of functions. First one is one-to-one function. Second one is on-to function. Another one is bijective function. Bijective functions means it is function one function and also on-to function also. Then the function is called bijective function. It's also one function is also called as injective function. On-to function is also called as surjective function, and if a function is injective and surjective, then it's called bijective function. First we know about what is one function. Types of functions. First one function, or it's called as on-to one function, on-to one or one function. It's also called injective function. First of all, we satisfy the conditions of the functions. Then the condition of one. Its name itself said that one function, one element having one separate image. One element of domain have the separate image. It's not image of the other. One function, a function f from x to y. It's represent a function from x to y. X is a domain, y is codomain. We represent a function f is a function from x to y. X to y is defined to be one if the images of distinct elements of x under M are distinct. Distinct means separate. Distinct means separate. Separate elements or separate image. You yourself remember here all elements of A or domain should have separate image. Means here A or B is an f is a function from A to B 1, 2, 3, 5, 6. It's a 1, it's a 6, 7. Yeah. 1 is having the image f of 1 is equal to 5. F of 2 is equal to 6. F of 3 is equal to 7. It's the image. 5, 6, 7 are the image. 1 having the image 5, 2 having the image 6, and 3 having the image 7. Here 1, 2, 3 elements of A having the separate image in B. Therefore, it's a one function. It's a one function. One function. Yeah. Every element of A should have separate image in B. Then only if it is having 3 is having the 6 the image, images. 2 and 3 having the 6 image. Here 2 image of 2 also 6. Image of 3 also 6. It's not a one function. It's a different function. It's a many one function. Then it's called as many one function. Many elements have the same image, therefore it's called many one image. Many one function. Next one is onto function. Onto function. Onto function, it's a surjective function. It's also known as surjective. Surjective function. Here, surjective means here the elements of A or domain having the images, not separate. It may be two elements have the same image, but one thing is important here. All the elements of B or codomain should be the images of the elements of domain. Elements of the domain. Every element of B should have the images. Image. If it is 2, 3, it should be the images of the elements of the domain A. There is no element should remain like that. Therefore, the onto function, in onto function, the range of codomain is equal to range of the function. Codomain is equal to range of the function. It means all elements of codomain are the images. All the elements of the codomain are the images. Then only you call it as onto function. If every element of Y is the image of some element of X under F. If every element of Y is the codomain, is the image of some element of X under F. Here 2, 3, here A, B, C. It's an element. If it is 1. It's a domain elements are A, B, C. In the codomain 2, 3. 2, 3 are the images of A, B, C. It may be the images of 2. 3 is the image of B and C. It's okay. But here, no element is remaining. It's not an image of B, X. Therefore, 2, 3 here range is equal to 2, 3 and codomain is equal to 2, 3. Therefore, it's a one onto function. Yeah. Here separate images are not there. Therefore, it's not one function. Yeah, B is having the image 3. C also having the image 3. Therefore, B and C are having the same image. Therefore, it is not one function. images or elements of the code domain are images of the elements of A or X domain. Therefore, it's an on. Next, bijective function. Bijective function. If a function is one or one and on to function, then the function is called on to function. Here you can put that here A B 1 2 3 A B C. Here 2 3. Let me say function here. One is having image B, f of 1 is equal to B, f of 2 is equal to A, and f of 3 is equal to C. Here, 1, 2, 3 of the elements of A having the separate image A, B, C or B, A, C respectively. 1, 2, 3 having the images BAC, different or distinct images, therefore its function is 1. Then the elements of B, A, B, C are codomain, elements of codomain are the images of elements of A, any element of A. Therefore, A, B, C are the elements of codomain and range also. Therefore, the function is on. Therefore, the function is bijective. Is bijective. It's injective as well as subjective. Therefore, we call it as the function is bijective function. If you first check the function is on one and on two, then if it's both are satisfied, then you call it as it's a bijective function. We take one example here. Example, if A is equal to 2, 5, 7, B is equal to 6, 8, 9. F is a function from A to B given by 2, 6, 5, 8 and 5, 6. Check. one or onto or bijective. Here A is equal to 257, B is equal to 689. The function from A to B given by here only given here the function element. Here 2 is the element of domain, 2, 5, 5 are the elements of domain. Therefore, it's not a function. It's not a function because by having two images. By having two images. 2 having the image 6, but 5 is having 8 image and 5 also having 6 image. Here, therefore, it's not a function. It's not a function. If I change this one, 2, 6, 7, 8. Then 2, 6, 7, 8, 5, 6. Here, the function is 1, 1 or 2 or by check this. Here, 2 element of 2 having the image 6. F of 2 is equal to 6. F of 7 is equal to 8. F of 5 is equal to 6. Here 2 also 2 and 5 elements of domain having the same image 6. Therefore, it's not 1 1 function. 1 1 function. And the elements of codomain is equal to 6, 8, 9. But range is equal to 6 and 8. 6 and 8. Therefore, here codomain is not equal to range. Codomain is not equal to range. Therefore, it's not onto function. It's not onto function. Like this, you check the function is 1 1 or onto function. First, images are separate or not. Every element having the separate image or not for 1 1 function. And second, onto function, every elements of codomain is equal to range. Is equal to images. You check these two conditions. Then you justify the bijective or injective or subjective function. Here the questions are from somewhere different. Show that, example, show that the function f from n to n given by f of 1 is equal to f of 2 is equal to 1 and f of x is equal to x minus 1 for every x is greater than 2 is onto but not 1. Yeah. Show that the function from n to n. Function from n to n means n is the natural number set. Is the domain also natural number set and codomain also natural number set. Given by f of 1 is equal to f of 2 is equal to 1 and f of x equal to x minus 1 for every x is greater than 2 is on to but not 1. Here f of 1 is equal to f of 2 is equal to 1. Therefore, here f of 1 is equal to f of 2 is equal to 1. But 1 is not equal to 2. 1 is not equal to 2. Therefore, the function is not 1-1 function. It's not 1-1 function. Then on to function f of x equal to x minus 1. Here, we check that x minus 1, f of x equal to y. X is belongs to domain, y is belongs to codomain. Therefore, y is belongs to codomain. We take the here the function is n is a function from n to n. Here 1 2 3 4. Here also 1 2 3 4. Here y is a 11. It belongs to n in codomain. We find any element in domain n. It's an image. We check if exists any pre-image in domain. F of x equal to 1. Here f of x is equal to x minus 1, which is equal to y. Therefore, x equal to y minus 1. Y plus 1. Here it belongs to n. It belongs to n. Every x is equal to y plus 1. Here, if it is y, here y plus 1 is the image. Y plus 1 in x. Y plus 1 having the image y because f of y minus y plus 1 which is equal to y minus y plus 1 minus 1 which is equal to y. Here element of y plus 1 in domain having an image y in codomain. Therefore, every element of y having an pre-image in domain. Therefore, the function is on. Every element of we can't check the every element here because it's an infinite set. Therefore, we check like this. Any element of y belongs to codomain f of x equal to y. Then we write x equal to y plus 1. Y plus 1, if it is y minus 1, it not belongs to n because if it is 2 minus, if it is 1, it's minus 1 which is equal to 0. 0 is not belongs to n. Therefore, it's not a onto function. Here we check the function. We should know about the elements of the set also. Here, sometimes n to n here is given. Sometimes it is q to q or r to r. We know about the set of the q or r also. R is the set of real numbers. Z is the set of integers. You should know about all sets also here. Once again, recall all sets, number sets. Then another function, another problem. Show that f is a function from q to q defined by f of x equal to 3x minus 5 is bijective. Is bijective. First means its bijective is 1 1 and on 2 also. First we check the function is 1 1, then the function is 1 2, then if it satisfies then the function is bijective. First we check the function is 1 1. The condition we check like this: for all x1 and x2 belongs to Q. We take the x1 and x2 elements belongs to Q. Here f of x1 is equal to f of x2. Here f of x1 is equal to, we put the value x1 here, 3x1 minus 5 is equal to, in the same way we put the substitute x2 is equal to 3x2 minus 5. Here minus 5 cancel. 3x1 is equal to 3x2. Here also 3 cancel. Then x1 is equal to x2. F of x1 is equal to f of x2. Then x1 is equal to x2 also. Then only we call it as 1 1 function. If it is not equal, the function is not 1 1. The function is 1 1. Then want to find. Here we select any element in Y or codomain. Every element, every Y belongs to Q. Belongs to Q. It's a codomain. Q means here Q codomain because identical, because here domain also Q and codomain also Q. It belongs to codomain. Then there exists X belongs to Q. It's a domain. Every Y belongs to codomain having a pre-image in domain. It's a X. Every element of Y should have any pre-image in X. Then only it's a order function. Every element of Y should be the images of the any element of codomain. Domain. Element of the domain. Here f of x equal to y is equal to f of x. F of x equal to 3x minus 5 is equal to y. Therefore 3x is equal to y plus 5. X is equal to y plus 5 by 3. It sometimes it's a rational number. Y plus 5 is 3. It belongs to Q. It belongs to Q. If we give here is a natural number set, it don't belongs to any natural number. But y plus 5 by 3 is belongs to Q because it's a rational number set, therefore it belongs to U. Therefore, it's a onto function. The function is one and onto function, therefore the function is bijective. This type of question will ask you 3 marks question. First you check the y1 function and onto function. Then conclusion, the function is bijective or not. If it's y1, if it's not onto, then it's not a bijective function. Both are satisfied, then only we write it as bijective function. If a function is from R to R, defined by greatest integer function. Greatest integer function is f of x equal to like this. Its greatest integer means here if 1.5 greatest integer of 1.5 is equal to 1 itself. 1.7 also is equal to 1. Here f of 1.5 is equal to 1. F of 1.7 also equal to 1. But 1.5 is not equal to 1.7. Means x1, f of x1 is equal to 1. F of x2 is equal to 1. But x1 is not equal to here x2. 1.5 is not equal to 1.7. Therefore, it is not a 1 function. Then on to function also. Here 1.5 is 1. 1.7 also having the element image 7. 1. It's from R to R. Here 1.5 also here. But 1.5 not having a field image in domain. Therefore, it's not a onto function. It's not a on-one function. Neither on-one nor onto function. And another one, Sinum function. Sinum function is f of x is a function from R to R. Here f of x equal to 1, 0, minus 1. If x is greater than 0, if x is equal to 0, and if x is less than 0. Here, all elements of greater than 0 having the image 1. Having the image 1. And all elements of less than 0 having the image minus 1. If it is 0, the image is 0. Here, therefore, only 1, 0 and minus 1 are the images. Other elements of R are remaining as it is. Therefore, it's not an onto function because here real set many elements are there, but minus 1, 0 and 1 only the images of every element of minus 1, 2, minus 2, minus 3 or 1.1, etc. Here, these are the image having the images minus and etc. Here the images less than 0 are having minus 1. Here also minus. Minus 3 also having minus. Plus 1, 3, 2, and 3 also having 1. And if it is 0, everything is 3. But here, the elements of domain are not having the separate image. Therefore it is not a one function. And the images of set of images of codomain are not equal to the range. Here images set is 1, 0, minus 1 is not equal to R. Is not equal to R. It's a real number set, codomain. But image set is 0, 1 and minus 1. Therefore, there are not equal. Therefore, it's not an onto function. Therefore, N functions are not 1, 1, neither 1, 1, not onto function. We will take another example here. F is a function from R to R defined by f of x equal to 1 plus x square. 1 plus x square. Here, the function is from R to R. Domain is real number set and codomain also real number set defined by f of x equal to 1 plus x square. We check the one function and one-to function. Here, first we check the one function. For all x1, x2 belongs to R. Then f of x1 means here domain. R means here domain. F of x1 is equal to f of x2. Then f of x1 is equal to 1 plus x1 square is equal to 1 plus x2 square. 1 cancel. x1 square is equal to x2 square. Sometimes you write it as x1 square is equal to x2 square, x1 is equal to x2. It's not right. Here x1 square minus x2 square is equal to 0. Here x1 plus x2 and x1 minus x2 is equal to 0. You write x1 is equal to x2 if the set is natural number n to n. If it is given n to n natural number set, then minus negative numbers are not belongs to natural numbers. And you can take here x1 is equal to x2. But in this case, it is R to R. Here negative numbers also included here. Therefore, x1 into x plus x2 and x1 minus x2 is equal to 0. Therefore, x1 is equal to x2 and x1 is equal to minus x2 also. Therefore, x1 is equal to plus or minus x2. Therefore, it's not a one function. But if you write it as x1 is equal to x2, take this one. In natural number set, it's a one function. But in R to R, real number set, x1 is equal to plus or minus x2. Therefore, it is not a one function. Because here 1 plus x1 square f of 1, I taken it as 1 plus 1 square is equal to 1 square is equal to 1 is equal to 1 plus 1 is equal to 2. If f of minus 1 which is equal to 1 plus again it's a minus 1 square is 1, it's also 2. Here we write it as f of minus 1 which is equal to f of plus 1, but minus 1 is not equal to plus 1. Therefore, it is not a one function. Then, onto function. Onto function, we take any element y belongs to R, which is codomain. Here, y is f of x equal to y. Here, f of x equal to y. F of x equal to 1 plus x square is equal to y. X square is equal to y minus 1. X equal to y minus 1 square root of y minus 1. But here all numbers belongs to here 1 plus x square. X is belongs to R. But all elements of R means codomain are not equal to range, because 1 plus x square is equal to, I will check this here, every element 1 plus something greater than 1 elements are images of the elements of x. But less than 1 are not the images. Less than 1 are not the images of the elements of x. Therefore, codomain of the function is not equal to range. You check the range is equal to codomain or not. It's not equal. Therefore, it's not onto function. Some problems I give you. You do yourself only in the home. You check the steps involved in finding checking the 1-1 function and 1-2 function. For 1-1 function, you check f of x1 is x1 and x2 belongs to domain. If it may be R or Q or given set, then f of x1 is equal to f of x2. Then put the values in a function. Then if x1 is equal to x2, then only it's a 1-1 function. If it's not equal, it's not a 1-1 function. If check the onto function, you take any element of y belongs to codomain and find the respective x in domain. Is there or exist or not? If you can't check this, range is not equal to codomain or not. If range is equal to codomain of the function, then the function is onto. Then hereby you check the 1-1 function and 1-2 function and find the bijective or not. Next class I will discuss about composite functions. You do yourself all the examples given in the exercise problems. Solve yourself. If you have any doubts, please ask me. I will send you a PDF next week. Okay, thank you.